I'm Sebastien Bouteille from the Center for Tunnel Studies, a department of French Ministry of Transport. I'm going to present you our latest progress on the application of sprayed UHPC for structural reinforcement or protection. As you can see, Freycinet, Lafarge-Holcim, and the Gustave Eiffel University are particularly involved in this project. During this presentation, I will present you how to design the sprayed UHPC reinforcement has been approached, the different validations through the experimental protocol, the feedback and experimental site, and monitoring of other sites based on the same technical principle. And finally, I will discuss the lessons we have learned through this project and the current perspective. 5 years ago, Freycinet and Holcim Lafarge were candidates for the Road and Streets Innovation Program to develop this project with technical support from the Ministry of Transport. This innovative project consists in applying sprayed UHPC on the structural strengthening of metal culverts under roads and highways. It was expected from this new technology gains in terms of technical performance, production and maintenance cost, material consumption, and speed of construction. This strengthening solution was based on Lafarge-Holcim scientific and technical expertise in the field of UHPC and on Freycinet's know-how and experience in structural strengthening works involving wet and dry sprayed concrete. This innovative technical solution applies very well to corroded but not excessively deformed metal pipe culverts, which are quite numerous in France. This method allows the road authorities to now use a new semi-rigid strengthening technique that is more efficient and creates much less impact than the conventional approach based on a rigid and thick reinforcement that radically modifies the structure function. Now, let's go into more technical part of the project. As you can see from this table, the main characteristics of the sprayed UHPC are a compressive strength of 130 MPa, a characteristic value of limit of elasticity under tension of 6 MPa, and the characteristic value of post-cracking strength of 5 MPa. Spray UHPC also has a high abrasion resistance capacity. Energy absorption tests were also used to characterize the material. The results are relatively high, with 600 joules for a 30 millimeter slab and 1,300 joules for a 50 millimeter slab. UHPC is not covered by any Euro codes, even when cast in place. French standard so gives requirement for UHPC cast in place. And we also add a national addition to Eurocode 2 for structural UHPC with a minimal compressive strength of 150 MPa. Through the experimental program, we compared calculation and measurements. On the one hand, one specific test body to validate the calculation method, and on the other hand, on a scale 1 test specimen to validate the expected mechanical functioning. We have, of course, carried out the 3- and 4-point bending test to characterize the material. From the test result, we determine the constitutive laws to verify the sections corresponding to the shell set up in the structure. Then 12 bodies of UHPC sprayed on the corrugated sheet were tested with a 4-point bending test to determine the resistant moment. We obtain a safety coefficient higher than 1.7 by comparing the characteristic experimental values obtained on the test body and the moment calculated with the constitutive laws. This test confirmed that the use of constitutive laws to verify the cross-section applies well to UHPC with compression values of 130 MPa. A loading scale test 1 has been performed. The metal culvert was first reinforced and then loaded with the help of two transverse beams, transferring the forces of the bar to put in traction by jack. The wall was instrumented to follow the loadings, the deformation, and the stress values. Different loading and unloading cycles were applied. After determination of the elastic limit, the load was increased until the failure test body. So you can see on the left the test body before loading, and on the right, the test body after loading. The failure load reached 200 kilonewtons, which was the expected value. As for the failure load, the yield strength and displacement were found to be in accordance with the simplified calculation. An experiment was then carried out on a culvert on a national road. This is a corroded metal culvert, but without excessive deformations. This structure is a re-establishment of a rural road. It is sensitive to road operating loads due to its low coverage. Calculations were carried out with a 3D model, including soil modulus from boreholes. The thickness of the sections makes them sensitive to any lack of material. The verification of the sections was therefore conducted excluding the original metal culvert assembly bolts. The mixing process of the UHPC, as well as its spraying, proved to be dedicated to master during the preliminary test. Therefore, the company decided to create a team dedicated to the realization of these works. A specific mixing plant has also been manufactured. The test result validated the mechanical characteristics. A compressive strength higher than 50 MPa at 1 day and 140 MPa at 20 days can be noted. The verification of the fiber dosage has given adequate results. Further investigation were carried out on the actual thickness applied. The average value on measurements was over 31.5 millimeters. All individual values were about 30 millimeters, and only 6 out of 60 measuring points were between 25 and 30 millimeters. Our sites, after this first experiment, other structures were repaired like this culvert on the A10 highway. You can visualize the preparation of the structure before the spraying of the UHPC. There on this picture. So the wooden boxes were also going to be sprayed to make the test bodies for the 3-point bending tests. This picture showed the application of the sprayed UHPC in this structure. And here you can see the structure after reinforcement with the sprayed UHPC shell. Another example of a project on the A36 highway. On the left, the preparation before applying the spray UHPC. And you will see on the right a picture that's the, well, you can see on the right picture that the culvert is relatively large and required a mobile scaffold for spraying. In 2019, the company has invested in the design of a construction plant. The production process is automated, which makes it possible to increase the rate of production. So on this floor, you can see the fiber feeder, the vertical mixer, and the control unit located at the back. The pump is located on the floor under the mixer. The produced UHPC is directly poured into the pump to be sprayed. The mixing plant is transported to the construction site by a specific convoy, and it's then quickly operational. The structure was sprayed on the totality of its perimeter, including the invert. This also required specific justifications. We have thus achieved the objective of realization and justification of a structural reinforcement of a metal culvert by a thin shell in sprayed UHPC. The operational controls were also established and validated. So the company now has a dedicated team to carry out this work, and the spraying of a UHPC remains a delicate process to master. Some optimization are possible on the production line. The control and stability of the implementation must be reinforced. And as with any in-situ spraying project, the sensitivity of the environment remains delicate to manage. Typical new development are planned. We expect to characterize the rise in comparison at the young age. For this, tests with an activator to obtain 3 MPa at 3 hours are to be planned. The characterization of the water tightness of the spray UHPC thin shell could also be useful in underground works. Other specific characterizations could be developed later. For example, the fire resistance under a normalized load case, but also resistance to penetration of aggressive agents in a marine site, and especially in a tidal zone. So thank you for listening. If you have any question, I will try to answer the best as I can.
Thank you for this excellent presentation as well. Very informative. It's interesting what else can be done with UHPC in a sprayed application. I think it opens up so many opportunities to apply UHPC as a repair material over here as a tunnel lining. Excellent. But I must, in terms of material properties, it must be difficult to develop a UHPC which has the right viscosity to stick and to build up a certain thickness. Is this correct?
Yes, it's the major difficulty that the company had to manage first. It's to target the compromise between the pumping necessity of the production UHPC and the possibility to have a good adhesion to create the sprayed and a good adhesion when you spray the production UHPC. Sorry for me, English. It's not very correct, but I expect you understand my answer.
Oh, absolutely. Your English is totally fine. Thank you so much for sharing this and being part of this session here. Are there any publications out there where researchers can read about for example, the mix properties or the development of this mix of sprayed UHPC?
Yes, of course. That was the first part of the project. And we've already communicated on this field. So perhaps when I will send you the presentation, I will add some article which are of this field.